So, a very good evening to everyone, and thank you so much for joining in. Today's webinar covers the basics of PostgreSQL database. We'll be understanding what SQL is, what the PostgreSQL database is, and how we can make tweaks and add data and modify data to our PostgreSQL database. My name is Dushyant Pathak, and let's quickly go on to today's agenda. We will get first an introduction to what SQL is, that is structured query language, which is actually the language that is used to query data from the databases. We'll get to an understanding of what the PostgreSQL database is, and then we'll head on to create a database, create a table in the database, add data to the database, and play around with the data. A quick word about me. My name is Dushyant Pathak. I've been building and breaking stuff for a few years. I have over 3 years of experience in the industry, and I have had a few share of my interviews on both sides, and which means that I have some idea of the importance that PostgreSQL and in general SQL has in today's market. With that out of the way, let's dive into the topic. This one. So first of all, PostgreSQL or even any other database that you think of, it has the word SQL inside it. And SQL stands for Structured Query Language. So just like you have your languages of C++, Java, it is somewhat similar. It is a programming language. However, it does not allow you to write applications or logic the way these other languages do. However, SQL is a language that is used to query databases. So that's why the name structured query language. It gives a structure and it is used to query the database. So that's the first thing that's out of the way. SQL stands for structured query language. Now remember that the databases might be different, but the way to access data into those databases is always via structured query language. ठीक है? And why exactly do you think we need this language? Okay? Because anytime we think of a database, our mind automatically places it into a structure similar to an Excel document, right? A Microsoft Excel document or Google Sheets, wherein the data is present in the form of rows and columns. And that is very true that most databases that we'll talk about today are in the form of those rows and columns. However, when we use databases in our production applications, we cannot actually use them as Excel statements. We cannot look at it and do something. We need a method to retrieve the data from the database from within our application logic, and for that reason we need this SQL. So SQL is a language which provides a syntax which would allow us to retrieve, add and update data into the database. Okay. So that is SQL. It looks something like this. I have added a couple of random statements that would give you an idea of what SQL looks like. Select star from table. So what this will do is that it will select all the values, all the rows that are there in a given table, which is defined by the table name. And if you want to add data to a table, it will be insert into table the following values. All right. So like I said, SQL is the language to be accessing the database, and some of the most common SQL databases are PostgreSQL, which is what we're going to be looking at today, MySQL, SQLite, or SQL Server. Remember that all of these have the common term SQL in common. It is not necessary that for a database to be an SQL database, it has to have the name SQL, but for the most part, any database that is of the format of SQL has the name SQL inside it. All right. So now all you have heard me talk about is SQL databases. So are there databases which are also not SQL or which do not follow this format? So yes, these are known as NoSQL databases, and interestingly, NoSQL does not stand for not SQL, it stands for not only SQL. So these NoSQL databases oftentimes employ strategies of forming the tables in a way that its syntax, the syntax that is required for fetching data and updating data into it, is somewhat similar to SQL, but it need not follow the exact rigid structure that SQL and SQL databases follow. All right, so what exactly do I mean by it? For all of these databases that you see on the screen, be it PostgreSQL, MySQL, SQLite, or SQL Server, the format in which these will be present is that they will always have to be present in the form of rows and columns. That is requirement number one. All of these have to have a predefined schema. So you will hear this word schema played out very often. So schema means the structure of the columns. So what all columns are there in the database, and more importantly, what is the data type of each of these columns. For instance, the example that we are going to be looking at today is example creating a student table. So what all properties will a student table have? It will have the student ID, it will have the student name, it will have the student age, and it will have, let's say, some courses that the student has taken. So student ID will be in the form of an integer, name will be in the form of string, age will also be an integer, and so on. So this collection of the various columns that a table has, along with its data type, is known as a schema. So whenever you hear the word schema, you have to think of columns. All right. So the difference between SQL and NoSQL databases is that SQL databases enforce a schema. Remember this very carefully, and make sure that this phrase is set in your mind, that SQL databases always enforce a schema. They have a rigid schema. So whenever you try to insert into the database, you have to make sure that all of these values are present, and they are present in the structure that is given. ठीक है? If you were to insert a value into the student database, you have to make sure that the structure you follow is that every entry should have an ID, a name, and age, and a course. If in case there is nothing here, you can enter null. However, it has to follow this format. In contrast, if it were a NoSQL database, then you need not follow this exact structure. The most common example of a NoSQL database is the MongoDB database, which is something that you would have heard of often. We also had a session on MongoDB earlier, last to last month, in which we had discussed what are the differences between MongoDB and an SQL database. So in MongoDB, you might have a schema. Might have defined a schema. However, if you were to add new entries into that schema, you need not really adhere to that schema for every entry that you add. You can go a little bit above and below in terms of what all values you are adding to the database, right? So this is the very primary difference between an SQL database and a NoSQL database. That SQL databases will always follow a schema. NoSQL databases like MongoDB might have a schema, but they do not enforce it. So you can tweak the schema a little bit for some of the entries. All right. So if you are ever asked in the interviews what are the differences between SQL and NoSQL databases, this is what you have to answer. Right. So what exactly does an SQL database look like? SQL databases. So if someone were to ask you what an SQL database table looks like, an SQL table is a collection of rows and columns. Now, rows in SQL database terminology are known as fields, and columns are known as records. All right. Get me? Just give me one sec. I might have jumbled these two up. Let me just quickly confirm this. There is a slight typo here. Let me quickly correct that right away. Rows are referred to as records and columns are referred to as fields. So let me quickly make that change. Rows are referred to as records and columns are fields. All right. So when someone asks you to define what an SQL database table is, then an SQL database table is a collection of rows and columns or records and fields. ठीक है? PostgreSQL, like we just saw, is an example of an SQL database. All right. Now, how exactly do we see? So before we go on to the setup, let's quickly take a look at what this looks like. So this is what an actual SQL database would look like. So it has a set of rows. Remember, rows are known as, where did it go? Rows are known as records, columns are known as fields. All right, so these are some records and these are the fields. Horizontally it is records and vertically it is fields. ठीक है? Cool. And to set up PostgreSQL database. So come on, now this database has to live somewhere, right? You have to store the data somewhere. Okay, database is just a method for storing it. Where exactly is it stored? So first of all, if you want to create your own database, you have to set this up on your local system. So to set up a PostgreSQL on your local system, you will need two different things. You will first need the PostgreSQL software itself, and you will need pgadmin. PostgreSQL can be downloaded by going to postgresql.org and on downloads. And here you can download whatever version fits. So it will just give you an exe file, and you just have to run it and it will set it up. pgadmin, like the name suggests, it stands for Postgres admin. So it allows you to administer whatever requirements are there for your database. So essentially, PostgreSQL is the database. pgadmin allows you to manage the database. So configuring connections to the database, running SQL queries on the database, making sure who has access to the database, defining the port numbers for the database, seeing what all tables are there, what all views are there, what all indexes are there. All of that is possible using pgadmin. Like the name suggests, it is the admin dashboard for the Postgres application. All right. So PostgreSQL can be found out by going to postgresql.org/download, and you can download it from here based on whatever your system is. pgadmin can be found out by going to pgadmin.org and going to download. Again, similarly, pgadmin.org/download. Okay. So this is how you would download and set up a PostgreSQL database. All right. So that was about an introduction to Postgres, databases, SQL, and everything. Now we will head over to actually implementing this and seeing what this looks like in real life. All right. So to save us a lot of time in going about the setup and everything, what I have done is I founded an online compiler which will allow us to run and create databases and create SQL queries and run these SQL queries right in the browser itself, so that we do not actually have to set up and waste time on everything. All right. So that compiler is onecompiler.com. Let me go there quickly. If you head over to onecompiler.com and you select the language as PostgreSQL here, then you will be able to see some sample code written here. So it should show some biggish code for you. For right now, I cleared out that code and added a sample code. So just go over to onecompiler.com/PostgreSQL and you will be able to see this place, this editor, where you will be able to execute our SQL queries. If there are any questions thus far, please let me know on the chat. Otherwise, we'll move ahead with writing our first SQL query. I'll just give it a minute to take a break here and then we'll continue. All right, thank you. So the first thing that we would need to do is to create a database, right? So oftentimes we might get confused between what a database and what a table is. So database is a collection of tables. It can have zero or more tables. Table is one specific table like we saw in the screenshot. All right. So first thing that we need to do is we have to create a database, and each table will be part of a particular database. All right. So first, to create a database, what we are going to do is we are going to use the create database, and here we specify the database name, which in our case we will just name it college. All right. So the SQL syntax will be highlighted in this purple color. Usually, SQL recommends that you write SQL syntax in uppercase, that is in all caps. However, even if you write it in small caps, it will actually execute it. However, for best practice, you should try to make sure that as much SQL that you write is in uppercase, in all caps. All right. So this will create a database called college, and after we create the database, we have to use this database. So what we'll do is we'll do use. Let's just execute this once and then we'll go to the next step. Okay, permission denied. All right. So it won't allow us to create a new database here. We will just have to use the existing database. But just to give you a rough idea, if you want to create a database, what you have to write is create database college, and below it you have to write use college. What it will do is it will create this database and it will allow you to use the database, means it will switch over to this database and you will be able to create your tables within this database. Right now, we are not able to create this database because it is an online compiler. It is freely provided, and that means it has a default database which we have to use, and it won't allow us to create a new database. See, like you see, it shows that permission is denied to create the database. Yeah, cool. But we can still use the default database, and we can create our tables. So now what we are going to do is we are going to create a table. So the syntax for that is create table. Again, the SQL syntax will come in all caps. And now we have to specify the name of the table, which in this case we will name it student. After student, we give parenthesis. Now, here we have to specify all the fields of the table. Fields, remember, is columns. Rows are records, fields are columns. All right. So for the student table, let's try to take random guesses about what the student table could contain. We've just seen it a few minutes previously. One thing it could have is the ID. So we'll give it int ID. Syntax adding for adding the values into a database is ID space int. So it will specify the name of the column, comma, space the data type, and we'll have the name, which is a string, or in string is in SQL terms is known as varchar, which means it is a character string of variable length. So it's known as varchar. Next, we said that we would specify an age, which will be an int. And then let's say we specify course, which is also a varchar. Let's say we are just specifying on a particular course that the student is majoring in. All right. So this will allow us to create the table. Remember, after every SQL query, we have to specify a semicolon, which will make sure that this query is complete. So now if we run this, it said that it just shows create table, which means a table is created. But yet we do not see the table, right? We do not see it anywhere. We do not see how it looks like. This is because we have created the table, which means we have created the schema for the table. Again, remember, schema is the actual columns and the data types of all of these columns. So we have this template ready, we have the skeleton ready. However, the table will come up only once we have actually added data. So how do we actually add data into our SQL database, into our Postgres database? So for that, we use the syntax insert into student values sec. Value should be also caps, although since it's not syntax highlighting, so I just wondered if or not I should keep it that way, but let's keep it this way. So insert into student values. First of all, we have to specify an ID. So for the first student, we'll just specify 1. Name we'll specify as user1. So user1. Age, let's say 24. Course is, let's say, CSE. All right. Now let's run this. What it showed us is that it just showed that that something insert. All right. So again, this will still not immediately show us what exactly has been inserted, because right now it has been inserted. Now to actually see the data, we actually need to retrieve it, right? We need to print it out. So to print it out, what we have to do is we have to use what is known as the select syntax. So please pay careful attention here, because select syntax is the most important and most commonly used syntax across everything in Postgres or any SQL query language, in any SQL database. So it is select star from table name. So in our case, table name will be student, right? What select star does is it will select all possible values of all possible columns from the student table, as well as all possible rows. All right, let's print this. Now you can see that we have created a table with ID, name, age, and course. ID is 1, username is user1, age is 24, and course is CSE. All right. So we had added one value, added a row, and we are also able to see it now. Let's create a few more so that we are able to see it better. ID 2, user 2, age 27, course, let's say ECE. ID 3, user 3. Now let's just for some uniqueness, we'll give it null, right? So like I said, that if it does not have a value, we have to specify null. And for course, we'll just specify, I don't know, ME, mechanical engineering. All right. Now if we run this, you'll be able to see user 1, user 2, user 3, age 24 CSE, age 27 EC, and blank, that is null, and course is ME. All right. So we have added 3 different values and we are able to see all of them in the database. So through this, you got an understanding of what it is to insert into the database and to read values from the database. All right.